Well, it's only natural that we make things more interesting. What we've seen so far, the problems have been, I don't know, a little on the boring side. Maybe it's because of the way I'm talking today. But you wouldn't know. Thanks for noticing. So, we've got a lot of things here, right? We have a lot of fractions, and I know you guys are probably freaking out. But you don't have to. We've seen these guys before. How do we clear fractions?
Oh.
No. We're going to clear fractions. We find the common denominator for the whole problem. What's the LCD for everybody? The least common denominator is 8, right? So one of the ways that we had for solving this was to multiply everybody times that LCD. And when I say everybody, I mean everybody. Multiply everybody times 8. Now, simplify. If you really are multiplying times the LCD, you shouldn't have denominators when you're done simplifying. Because 4 is going to go into 8 how many times? It goes in there twice, so we just have 2x minus what? So 2x minus 3, because these 8's give me a 1, equals what? 8 times 2 is 16. Because see, the denominator for 2 is 1. So there's nothing really to simplify. Look, we don't do 40 divided by 2 when you make your number smaller. 2 goes into 8 4 times, so then 4 times 5x is 20x. Okay. When I look at this equation, is it quadratic or is it linear?
It's linear.
How do you know it's linear?
Because there are no doses.
There are no exponents here, so this guy's nice and linear. So get all of your x's to one side and constants to the other. That's what we used to do. How am I going to do that here? So if I move the 2x to the right side, that's going to give me what? That gives me 18x. Move the 16 to the other side, and you get what? So divide both sides by 18, so what does x equal? Negative 19 over 18. Now that's not the only way of doing this. There are two ways for clearing fractions. This is just one way, and I want to show you both ways so that when I give you a more complicated looking equation, you pick the way that works best for you. Okay, so let's redo this guy. 1/4 x minus 3/8 is equal to 2. Plus 5/2 x. Now, we had already established that the LCD was 8, right? And since I'm working with the exact same problem, it's still going to be 8. But here's what we do for the other way. What you do is that you get everybody to become an expression that has a denominator that's 8. So what would you need to turn this guy into an 8? What factor is he missing? Just like the factors that you see on the sideboard when we're adding and subtracting, what factor is missing here? Missing the factor of 2. What's missing here? But if I do a 1, does it matter? No. What's missing here? He's missing the whole factor of 8. What is this guy missing? We're missing a 4 there. So when we rewrite this guy, you see that we have 2x over 8 minus 3 over 8 equals 16 over 8 plus 20x over 8. Do y'all agree with that? So the method here is a little bit different than what I did above. Once you have everybody with the same common denominator, you don't need that denominator anymore. If everybody is the same, you can cross that out. And really what's going on, the behind the scenes stuff, is that you're multiplying everybody times 8. If you multiply this guy times 8, what happens? The 8's reduce. You multiply this times by 8, you multiply this times 8, what happens? The 8's reduce. The 8's reduce, the 8's reduce, right? But notice what I'm doing here. When I clear fractions like above, when I multiplied everything times 8, or here when I'm crossing out these denominators, it's only because you have these guys in an equation. You know that there are certain things that are legal to do in an equation that you can't do in an expression. Like above here, when I was talking about subtracting 16 on both sides, I can do that because it's an equation. If I didn't have the equal sign, you wouldn't have an equation, and you can't just subtract 16 from both sides because you wouldn't have two sides. So once these 8's are gone, you have the same equation that we had above. 2x minus 3 equals 16 plus 20x. Look, it's the same thing that we had before. Okay? The exact same thing, which means when I finish this, I'm still going to end up with negative 19 over 18. So it's really viewer's choice. You get to do whichever method you want to do. Some of these equations are set up so it's easier to do it the way where you're just getting everybody to have the same denominator, like here. Other equations, it's best if you can clear out the fractions by multiplying times the LCD. So let's look at some of those.